Most people think drowning looks like the movies. Arms waving, screaming for help, a dramatic struggle visible from shore. That is almost never what drowning looks like. Real drowning is quiet, still, over in minutes. And what happens inside the body during those minutes is one of the most precisely choreographed and brutal sequences in all of human physiology. Let's go through it, step by step. Drowning doesn't happen all at once. It happens in stages. The moment a person goes under, the first response is instinctive. A gasp, then breath holding. The average person can hold their breath for 30 to 90 seconds. Trained swimmers longer. Panicking victims far less. During this stage, the heart rate spikes. Adrenaline floods the system. The body knows something is very wrong. As oxygen in the blood drops, hypoxia sets in. The slow starvation of the brain and organs for the one thing they cannot go without. This is where it gets strange. Hypoxia doesn't feel like suffocation. It feels, to many survivors who were revived at this stage, like a creeping, confusing calm. Thinking becomes slow. Vision narrows. The urgency that was screaming through the body moments ago begins to fade. This is the brain rationing its last resources, shutting down non-essential functions to protect its core. It is not peaceful. It is the body failing, one system at a time. Then comes the moment that decides everything. After between 60 seconds and 2 minutes of oxygen deprivation, the body does something it cannot stop itself from doing. It breathes. Not a choice, not a failure of will. An involuntary reflex that overrides every conscious effort to keep the airway closed. Water floods the airway, and the body's response to that is immediate and violent. The larynx, the entrance to the airway, seizes shut in a spasm called laryngospasm, a last-ditch attempt to block the water. In roughly 10 to 15% of drowning cases, this spasm holds. No water actually enters the lungs. This is called dry drowning. Death occurs from asphyxia, suffocation, rather than fluid in the lungs. But in the majority of cases, the spasm fails or relaxes, and water enters the lungs. Freshwater and saltwater drown you differently. Freshwater, which is hypotonic, gets absorbed rapidly through the lung tissue directly into the bloodstream, diluting it and causing red blood cells to swell and burst. Saltwater, which is hypertonic, pulls fluid out of the bloodstream and into the lungs instead, essentially causing the lungs to fill from the inside. Both paths lead to the same destination, cardiac arrest, usually within 2 to 4 minutes of water entering the lungs. But here is where the story gets complicated. Cold water, below around 15 degrees Celsius, triggers something called the mammalian dive reflex. It's a survival mechanism we share with marine mammals. The moment cold water hits the face, the body responds with a cascade of protective reactions. Heart rate drops dramatically. Blood is redirected away from the limbs and toward the brain and heart. Oxygen consumption falls. The body slows itself down to buy time. People have been revived after being submerged in cold water for up to 40 minutes with full neurological recovery. There's a saying in emergency medicine, not dead until warm and dead, meaning a person pulled from cold water with no pulse is not assumed dead until their core temperature has been raised and resuscitation has failed. Cold water is the one condition under which drowning becomes survivable at timescales that seem impossible. We've covered the physiology, but what is the subjective experience? Survivors who were revived early, before significant brain damage, describe a remarkably consistent sequence. First, panic. Pure, total, overwhelming panic as the body fights to reach the surface. Then, as hypoxia deepens, confusion, a strange detachment, the world becoming distant and soft, and then, for most, nothing. Consciousness simply stops. Not darkness, not pain, just absence. The body suffers enormously. The person, at the very end, may not. That distinction matters. Drowning kills approximately 236,000 people every year worldwide. It is the third leading cause of unintentional injury death globally, and the majority of those deaths happen within 25 meters of safety. 25 meters. Understanding what drowning actually looks like, quiet, fast, invisible from shore, is not just fascinating science. It is the difference between seeing it in time and missing it entirely. Links below. If this kind of content makes you think, subscribe. There's more coming.